Okay, this is Derwin King with Samson Community College, and this is the MNT 110 class. And we are in the shop today. And Brandon, if you're watching, we hope that you and your family are doing better, and that you'll be back with us soon. And hello to anybody else that may be watching. Today we're going to be working on clutches and brakes. I'm going to take you over here to show you what Darren and Luke are working on. Got your mask, yeah. Keep the mask on all the way up the nose and everything. Yeah, everything. Okay, now, so these guys are working on pneumatic clutch and brake. And so here you've got a directional valve. You've got a directional valve that'll do clutch. It'll engage that regulator to do a clutch, and the clutch is on the back end here. It's belt drive that's off right now. And then when you flip it over that way, it's going to go brake. It'll engage that regulator. It's going to do a pneumatic air brake for this brake lock on the transfer truck. They're breaking it down. They're going to put it back together, do an alignment. They'll do a reassembly. They'll do an alignment here with the motor and the driven in. This is our simulated machine. And so I'm going to back on off and let them guys continue with their breakdown and reassembly. And me and Patrick are going to come over here and start another lab at the same time. So while they're doing that busy, we're going to be over here working on an electric brake motor. And right here, Patrick, I got the data sheet. Come on over this way. Motor. This is an Italian brake motor. It's a high-end three-phase motor that has a magnetic brake on the back of it, magnetic coil with a brake pad. And there goes your coil in the back here. And when you energize and you put three-phase 480 volt on this thing, it does a couple things. It energizes a coil that pulls against the spring, and it allows a little gap in there. It'll a gap in there to get me to set it with a feeler gauge. It'll set a gap between the metal plates in there and that friction pad. You have friction pad in there that'll rotate, and we've got to produce a gap in there of 10,000. Where that comes from is in the procedure here for the brake motor. It's a type F, and the specification says that the magnetic gap distance must be adjusted approximately 0.3 millimeters, which would be about 10 thousandths of an inch in standard. And so our adjustment places would be these studs. You have 3 studs here, and we're gonna adjust these lock nuts and bring this whole assembly and kind of balance it to get 10 thousandths in 3 locations near where the studs are. So we have 1 stud here, got 1 down there, got 1 down there. That's one adjustment position, and then the other adjustment position is right over here. Right over here. So those are the 3. You get on from the end of it. You can see 1, 2, and then 3. So you can see all of them from the end like that. If I get my camera right there, you can see all 3 of them now. There's going to be kind of a balancing act there to try to get as close as we can to 10 thousandths of a gap. And what that's going to do is it's going to give us enough clearance, just enough so that when it rotates, it's not going to drag. And then when the brake engages, it doesn't have but 10 thousandths to travel to engage. And so we're going to need, and they should be millimeters because it's an Italian motor. So everything should be in millimeters. And so we're probably going to need, if we measure that, I got a metric tape right here. I measured it. It's actually smaller than that. Yes, it's 14. That's it, 14. We can get 2 14s. If you don't have 2, I'll find another one because I've got some information in my box.
The snap key.
The what?
Snap ring to get the clutch down.
You can actually leave the clutch together. You don't have to take the clutch apart. You just leave the clutch assembly together. That'll be fine like that. Yeah.
Here's another 14.
Thank you. Okay. Lever gauge. You found the 10,000 already. And kind of it's a repeating here. Let's see that. I have one the other day. You can get it complete real easy what they do with it. I may have put it right back down in there. I will take the measurement from yesterday for the butterball. By the way, I put a new worksheet online last night for chapter 3. Everybody listening, there's a new chapter 3. Everybody needs to go and read that the weekend. That's going to be your homework. Chapter 3 on maintenance procedures and record keeping. It's on record keeping, like what you do, preventive maintenance, predictive maintenance, and all. It's on that stuff. It's all true, false, and multiple choice. It won't take that long to do it. That's one of them that's going to be considered a makeup sheet for the 2 days that we'll miss. Because on November 17 and 19, those are 2 days that you would normally be here before the exam. So the week before the exam, you won't be in here. There'll be a week gap that you won't be in here with me, but you'll be able to study. So what I would do is your study guide for the exam will be your own graded worksheets. If you go in Moodle and when you choose the worksheet that you've done, when you click it, on the right side of the screen, there's going to be a little button that says review. And when you hit review, you can pull it back up and see your answers and how it's graded. And you can print it to a PDF file on your computer and save it, or on your phone, save it to study by, or you can print it on paper. So y'all need to make sure and save your graded worksheets either as a PDF so you can study, or print them on paper, one or the other. Brandon, I hope you caught that. That your study guide, the exam is going to consist of some questions off of each worksheet, and it'll be a self-grading exam. It'll be true, false, and multiple choice. So I'll pick out an equal number of questions off of each worksheet. And the exam, you have to come in here to do the exam. You can't do it remotely. It has to be done in here at normal class time on the 24th of November. And they wouldn't let me change it. I was going to give the exam on the 17th, on the 12th, on the last day. They said the upper management won't let that happen, which is actually better for y'all that it don't happen, because if you got a week to study, you've actually got a whole week without me to study. So it actually kind of worked out better. I'd probably look at the sunny side. Usually a sunny side to a situation that's kind of what we didn't plan, and that would have to be the sunny side to it, Well, I kind of like to think that there is, So Brandon, or whoever may be watching this is a set of feeder gauges. Let's cut this little line on here. So you got a set of feeler gauges here with, get this thing positioned right. It's got different numbers marked on there. So if we find 10 thousandths, so right there you can see the 0.010 inches, that's 10 thousandths or 0.25 millimeters. And that's the thickness of it. You see it's real thin. It's roughly about like 3 sheets of notebook paper. Because notebook paper's around 3 thousandths. And so that's what we're going to use to set that gap with. It's not much at all, but it's just enough of a clearance in there to let the motor spin, and the brake pad will not be scrubbing or dragging on the metal plate to cause wear, continuous wear. You know, that's what we need to do. And what Patrick is doing here, I'm going to move the camera over here, to kind of get a bird's eye view of what he's up to. Camera will be a little bit rocky here. So what he's doing here is he's adjusting these lock nuts. This is going to allow him to move this coil assembly here. It's going to produce a gap in there, you know. And so he's like that. I love that camera, man.
Yeah,
that thing is nice. Man. Barney got them for us. They were there's a lady on campus that discovered these things, and she told everybody about it. And Barney ordered a bunch of them, and I actually got 2. I got one here and I got one at home. That way I don't have to pack it up and bend it every time. I got one for if I'm doing Zoom at home. So Patrick is doing, he's doing this adjustment here on that bottom one. Checking that gap there. And what he's shooting for is you want to have it to where you get a little bit of drag in there with that 10,000 cent. A little bit of drag, not a lot, a little bit. So he's locking his position in now. Go back around now. Actually, you're going to be famous not just in the music industry, you're going to be famous in the industrial maintenance YouTube world. You're going to be a YouTube star too.
You say so, Mr.
That's right.
I trust what you say.
Patrick Simpson here, y'all. This is the man right here. You got a reliability engineering technician over there at Bay Valley, and you're doing what else, man? Planner. Maintenance planner. He's gone from reliability technician, engineer to planner.
Let me check it. Change a little bit when I tighten it.
It will. If because there's only about 3 points, it's going to throw it off some. It's a teeter-totter process is what it really is. Do y'all have anything like this over there at the plant, Patrick? Do you know of?
Yeah, we have some breaks over there. Yes, sir.
All right. We're just going back now, checking that 10,000. And you want to have a little bit of drag in there. Mm-hmm. Okay, so are all of the outside nuts, everything locked in?
Everything's
Good?
tight.
Very good. So at this point, what we want to see is if you will spin the motor, and we'll see this spin freely. And it does. See it spinning, let me go ahead and look at it right through again. Y'all see it spinning freely? And I don't hear any scrubbing, do you? I don't hear any catching going on. I see a little bit of warpage in there. The plates, yeah, the plates a little bit warping. That may be why it was donated. Butterball donated those here for us for the guys to learn how to do this on. But if you notice here, spin again, you see how the shaft is spinning free. It doesn't have any drag to it. So it's nice and free. And that's on the shaft end. And then there goes the brake pad in. So that gives you a view there. If you notice here, if y'all notice the sparkly particles in that brake material. So you have the sparkly that resembles regular pads on a vehicle. You know, the mixture of how they make brake material. You know, it has metal particles all in there with it for to give you a proper amount of friction. A blend of friction and wearability. You know. So anyhow, what Patrick did here to be able to set it up to simulate the coil being energized is he screwed in a stud here, and you'll screw that back out. And screws that out, what it does is it lets the brake go back to a normally closed position. That basically simulates the electrical coil being energized, the magnetic coil being energized. And now you go over here, and it's locked up. The shaft won't turn. See, when it turns now, see absolutely no movement in that shaft. So it's called a brake motor, and the whole reason for having a motor like this is so that this motor is used at Butterball for some type of process where this is actually running some type of a plate up and down for vacuum packaging. And when it gets up to a certain elevation, there's a sensor that makes a proximity sensor that it sees. And when the PLC sees that, the PLC actually de-energizes the motor starter for this. When it's de-energized, then it de-energizes the coil for the motor, and it also de-energizes this electric magnetic brake, and it slams shut. The spring's put back, and it engages the brake pad. So it's a very fast stop. It's a really definite stop. It's basically, you could even call it maybe like an indexing motor, to where you can make it go up to a certain point, and when you stop it, it stops exactly right there. It's not as accurate as a servo. A servo would be extremely accurate with an encoder on the back of it. And I've actually requested to get some servo equipment, and it's going through consideration right now. But if this was a servo motor, it would have an encoder on the back of it, not a brake. But the encoder would send pulses back to a controller. It would monitor the position by way of pulses. And when it got to a program set position, then the drive itself would actually just cause the motor to stop, but it wouldn't be a physical brake pad. Servos operate electrically by stopping things very quickly. But this is like this would be the next thing under kind of a servo. You don't know the position of it. The way you know the position to stop something would be with an external sensor. And if you have a plate that this thing is controlling, when it gets up to the sensor, the PLC would in turn turn a starter off, it would de-energize, and it would block this stuff. It kind of gives you a roundabout way of having a good precise position. So our next thing here is we're going to take this over to where we can wire it up electrically and see the thing run. And we're going to energize and de-energize it to see that it'll run freely, and then when we de-energize it, it'll slam shut on the dime. So we're going to reposition the camera here. and get our motor set up, get it wired. So it's kind of, bear with me here on the camera, moving around here for a little bit. We're going to move this way. So we can roll this whole thing over. How you guys going over here? I'm going to give an update here to Brandon and whoever may be watching. It looks like they got it bugged down pretty good there. You can see the pieces how they got the brake unit disassembled, the springs. They've got the rotor there, and that's just like on the vehicle. They've got that rotor, and sometimes they have to be turned on the lathe when they get warped. And anyhow, they're getting ready to go back together with it, and that looks good in the part. So
You want to put it back together now?
yes, sir. Put it back together. Yep. Yeah, we got Darren Branch, you got Luke Matthews here, and they're doing a fine job there. On the other side of the red thing here. So we're gonna wire this motor here. It's a 3-phase 480 volt motor. So it has three hot wires in the ground. Three hot wires here on the ground. And we're going to use something called a motor control bucket to power the motor. So yeah, this bucket right here it actually came from the butterball plant, and we're gonna tie to a motor starter that's in here. There's a motor starter in there that engages, and when we cut the switch on like that, it's going to hand. When we go to hand like that, it's going to put 120 volts on the coil. It's going to engage that starter, and it'll be basically a manual starter. We're going to do it in manual. So we're going to disconnect this motor that goes to that drive motor. We're going to disconnect that and put this up straight to the bottom of that starter. Right now, this starter is actually supplying power for a power flex for a different application. We're just going to remove that out of the picture. Right now, what we have here is got a lockout device right here, and we have a short pigtail that goes into the top of the bucket, and it's bringing the 480 straight in instead of it being going in through the rear like it normally would with the stamp. I couldn't stamp that. It goes into the MCC structure. And we those, so that's not a hazard right there. Get straight in, and then it is just a normal bucket. In hand mode, we can run it direct that way. If it was an auto, it would leave that strip and go out to some remote station to start stop and come back and run it in automatic. We're just going to do it in hand. Let me get a screwdriver. on the bottom end there, that's our three-phase there. Just, what comes in here is it goes from the bottom of the circuit breaker up to the top of the starter. Yeah. Just hang on if you're watching the video. We can't get the camera in this bucket. Once we get the motor connected, we're going to do a close-up of the motor itself, of you seeing it when it runs and when it gets the brake, how fast it reacts. And that's the main thing you need to see for right now.
So got to have all big count.
But they're not really, you don't have any.
I wish it did.
They got walls, they got room, you can room. Maybe on another whole floor, but for the interstitial, that's not what they do.
Yeah, I used to work it on Carolina River.
We're just putting this here to the side there, and it will disable everything over here. And let's just make sure we plug it back down. Make sure we got to keep this like this. If this transformer is also tapping, here we got to put that out there. We're going to do it from right. We're going to remove that from there. So it's not. Pull that one arm out. And this won't take long. Y'all hang on to whoever's watching. That's feeding the primary on that control. I'm trying to manage my hair. Sometimes it has a mind of its own. Very good. Now, so the power goes into here, it leaves the circuit breaker, and it goes in the top here. Power motor in the bottom of the starter, the bottom of the other load, and then that switch actually just energizes the coil. That's all. That's just that simple. We'll bring our ground. We're just doing a little ground here on the outside. And our 3 phases. At this point, we're not concerned about which direction it's going to go in. I don't even have these labeled as far as 1, 2, 3. We don't care what way it goes. It can go either way. It doesn't matter at this point, but we don't really have to have it tied to the machine.
Just in case y'all didn't know, Mr. Durable was the best instructor out here.
I don't know about that.
Almost.
We try that. We try to think. That's not compliment.
Best shop that I have.
That's a nice compliment. I appreciate it. Well, I tell you what, I had tried just electric shores. I tried to make one shop because when we had to do everything online for so many months, you get back in here, it's like eating for the first time. You know, you get a bit big plate of food in front of you like you've been starving for a while. And I said, well, this time, while we're in here, we're going to make your own shop. And we're kind of behind on the book for where we normally be. But hands-on wise, I want to make sure that you didn't miss, you know, just in case if that virus was to hit again or something, that was actually my main worry. That if it did, we were going to get into all the land that we could before that happened. You know, that makes sense. I was just worried. I had a suspicious feeling the whole time. That when something like that hits, you know there's a possibility of getting again. And do here, but even on campus now, there's been some different areas that's been quarantined on campus. And I just hope and praying that don't happen to us. It's hard to judge that. I got a mirror I can put in. I don't think it's got anything in it did not do it. Now, my perception of death here is not good. Let's get my mirror. I got a mirror. I'm a dentist part-time. So if something happens out here at school and y'all need your teeth worked on, just give me a call. And I got a mirror here, and I'll work on your teeth. You need to get some cabinet drilled out. I got some little drills. I hook good. I'm gonna locate. Here. That's about you get it for about $2 for that. All those on. It's real lightweight, goes real small, got a pocket clip. So all those on is that's the best one I can find out there. It's not full. Usually for doing electric work, mechanical. got a three-phase hooked up. Got a ground hooked up. Now we'll show one close up of that. So down in here in the starter, that's the actual overload unit with a reset, and the three yellow wires is what comes off the bottom of the overload. And like open this up. Oh, that right there. This is the actual motor starter right here. That's the whole motor starter. And if you go in and we hit this switch up here, that manual switch, it's going to put power on that coil right there. And when it does, it's going to do the same thing as doing this right here. When I'm pushing in on the armature, that starter's going to pull in when the switch comes on to put power on that magnetic coil. So you got a coil here pulling the starter in for three phase. It's going to send three phase power out them yellow wires. That's going to come out here to this motor and make it run, and it'll open that brake up to run, and then when you de-energize the 480, then it's going to de-energize the windings, and it's going to re-engage the brake. So we go back over this way, get the camera out of the way. We're going to get ready to put some power on. So back this up. Make sure there's no loose connections in there. No loose wire. Do have ground hooked up. So at this point, I need to get some PPE on. And we actually need to bolt this thing down because when it starts out, it definitely has some kick to it. So we're going to bolt the motor down. And so my thoughts were to take a piece of angle iron and clamp it down, and then clamp the angle iron to this, so that it's stable. So y'all bear with me a minute. We're going to get a rig set up here, so this can be so it can be secured. Just get the C clamps. Yeah, I'll give this out. And actually, the major wants to use the width of that hard. Actually, that's a good thought. We may have some. That would actually be better. Yeah, right here. Be right back. We're getting something to rig the previous motor. Actually, I can hold the motor. That's what we were doing with butterball. If one person holds it, it will get done. That's okay. We'll just hold it. It's not like it doesn't jump like a rocket ship or anything. So let me, first thing, let me get my jacket on, PPE. This is only going to be just a brief demonstration, just to show you how the motor will. It'll stop right on a dime.
Acting on camera is hard working. Acting on camera is hard working.
So what now?
Acting on the camera is hard
Yeah,
working.
yeah, it is. Yeah, it really is. Yeah. Patrick knows all about the cameras. He's a producer. He produces some good old gospel soul music, and I mean it'll make you want to dance. Make me want to dance. That girl you produced Cynthia or something, really? What the name? Cynthia. Lord have mercy. You got that bass. You got that bass. People are walking out. Okay, so now we're going to we're going to plug in the main power for the bucket here, 480 volt three-phase. Okay, face down. You can wear that if you want to, that's fine. And we're going to engage, we're going high here. When you cut a bucket on like that, you're supposed to be on the side and engage it, and you're not supposed to be looking toward it that way, just in case if there is an arc flash, and I got this here off, so it's not going to come off. Okay. I'm going to stand over to the side. I'm going to look in the other direction. And we'll put it on, and then we'll engage the switch. And the reason why we're doing this is so that if there's an arc flash, it's not, hopefully won't be on the person. It would be out here in the middle of nowhere, okay? So I have to go in and do engage. Override here since there's not a front on this, and I'm going to cut it on. Okay, so I've got the switch on. We didn't have an arc flash, so I'm going to come back around. And we're going to reposition the camera so you can see the shaft start with. So we're going to move. Yeah. And again, I've got this PPE on because OSHA says if you're over 50 volts, you're supposed to have on protective gear for your hands and face and all that stuff. So you see that shaft is nice and still, right? So I'm going to energize, and it's going to go ahead and start. It's supposed to. If we're ready, here we go. Get turning, and when I de-energize, it stops right on time. One more time. It's sitting dead still. We're going to energize. You guys want to see this? Yeah, come on over and watch the motor. So right now it's dead still, and I walk it. Spinning. When I let go, it stops on the time. So that's the magnetic brake on the back of the motor that stops on the dime. So this can be used for precise positioning. So now if you can move the camera to the back end, let's focus on the brake pad. You guys come around and look. You see that sparkly material on the brake pad? The friction material in there, the black material with specks in it. You can actually see the metal particles like in brake material. You know, it's like semi-metallic pads. If you buy brake pads, they call them semi-metallic or whatever. Then that's what you're doing right there. Now, I'm going to hold this because it ain't bolted down. We're going to energize again. You ready? You see it spinning? If you watch that gap close up, you see it close up? There's no gap in there now. If we take the feeder gauge, where's that feeder gauge at? If we take the feeder gauge and get in there, right now, you cannot get it in there because look, the coil is released and it's now it's engaged. So you can't get the feeder gauge in there now. There's no gap in there whatsoever. And Patrick set it up with 10 thousandths gap, which is about like 3 pieces of paper. That's super thin right there. That's 10 thousandths. So when it engages, all you're going to have is 10 thousandths clearance in there to keep it screwed. So again, we're going to energize again. Here we go. 1, 2, 3. You can actually see a little bit of the gap in there if you look closely. Matter of fact, if I take my flashlight, I might be able to actually produce what you can see. Maybe see a little bit of a gap in there, maybe. You see? Y'all see that gap in there? Now, somebody help us right at that angle. We don't get too close now. If you see the gap in there, now watch that gap close when I de-energize. See it close? Now the gap close is going to reopen. See the gap in there? You see some daylight, and now you don't. Man, that closed up. That little bit of a 10 thousandths gap in there is what the manufacturer says it's supposed to have to give it free motion and not drag. When we first came over, when we first opened this thing up the other day, there was only about, 1.5 thousandths of gap in there, what you found was right. Which the previous class had left it with a lot of drag in there. Too much. If we could run it that way, it would actually wear that pad out premature, and we would be actually mixing the whole thing and putting the panel. Anyway, I'm going to shut this thing off, and actually we can measure what time is it? 10:05. We've actually got enough time to do a voltage measurement. Let's measure the voltage going to this thing, and we can check the amps. I can show you how to test voltage on a 480 volt motor. That could be a plus there. Let's get a voltmeter.
Where's that?
It may be laying. It's actually laying on that table over there. Yeah. And what I'll do, I'll use the probe. I'm going to let y'all hold the meter, and then let Patrick show the meter on the screen. And I'm going to tell you what I'm going to be doing here. If we take the camera just momentarily here, and I'm going to show you where I'm going to be measuring voltage at. But I'm not going to have it in the bucket while I'm actually doing it because it's just going to be too risky for for exposure for somebody else. But there's power in here right now. But down there where the yellow wires are, down at the bottom of that starter, I'm actually going to go. The first reads I'm going to do is going to be from each yellow wire out from the first one to the second. That's going to be called T1, T2, and T3 for the yellow wires are. So I'm going to measure from T1 to T2, and then T1 to T3, and then T2 to T3. And it should be somewhere around 480 to 490 in both cases. Then I'm going to measure from each leg to ground. So going from T1 to ground should be around 277 volts roughly. Then I go T2 to ground, and then T3 to ground. Each one of those should be about 277 volts to ground. Each phase to ground is 486 and 477 volts. And that's like if you take the square root of 3, that factor comes into play there with that 277. If you multiply 277 times the square root of 3, it'll equal 480. And that's just about the most condensed way I can explain why you get 277 to ground, and it has to do with the relationship in three-phase voltage. It's a mathematical thing, and that's about the best I can tell you. And then we're going to check the amps. We're going to put an amp clamper on each one of these wires, which is one of the motor. And we'll be able to show you that. We're doing that. We're putting the clamp on each phase conductor for the motor. So we're going to put the camera back around here. And I'm going to do the probing, and they're going to hold the meter and show you the numbers when we're doing that. So you got an AC volts? That's good. So if you can position, first of all, let's cut it on. Let's get it stabilized and get it on, okay? So we're going to hold this, and we're going to cut it on. Okay, so she's running. And so let's make sure that these leads can't get nowhere near around a rotating part. Okay, so the first read is going to be, I'll call it out by what I'm doing. And would somebody else like to do this?
No, you're right.
Would somebody else like to do it? Seriously. If you want to watch, you want to hold Dave, you want to hold the light, you see what I'm doing? So if you hold the light down in there, you actually could, if you want to move that camera, kind of show a little bit what I'm doing, that's okay. I don't have to see it. But I'm going to go now. I'm going now from T1 to T2. So what voltage are you getting?
3.1.
Huh?
3.1.
3.1.
Yeah, 3.2. Oh, there we go. 486.
486 volts. You got that on the camera?
Yep.
That's 486 volts. And now I'm going to go from T1 to T3.
483.
482. Now I'm going to go from T2 to T3.
483.
483. The nominal will be 480, but it can be actually as low as 460. It can be as high as like 490 in that range. Okay, now we're going to go from each phase converter to ground. I've got a ground connection right here on the outside, and we're going to go from T1 to ground.
279.
279. We're going to go from T2 to ground.
282.
Okay, 277 is nominal, but that's a middle low number. Okay, we're going to go from T3 to ground.
280.
Right. So we're actually a little on the high end, higher than 277, and that's because phase to phase it's actually higher than 480. I go back T1 to T2, and you're reading 481. You're reading about 5 or 6 volts higher than nominal. So that also means that your phase to ground readings are going to be a little bit higher too. Okay. So now the next thing is we're going to switch it over to amps AC. And we're going to read around each phase conductor going to the motor. And we're getting 4.79 amps for that leg. When you're checking amps on the motor, you get one phase conductor at a time in the plant. One at a time. Let's separate it good again. We go back again. Make sure I get all three of them. We got you see that well? 4.79, 4.95, 4.95 or 92, and then 4.79, 4.78. Okay, so they're all pretty much balanced. When you're doing maintenance, checking motor current, those three should be similar. If there's an extreme difference in one of them legs on current, then you want to back up and check the voltage each leg of the ground. So let's say, for instance, to give you an example, we're going to cut this off. Now, for instance, I'm going to give you two scenarios that will kind of point in the direction of what could be a problem. Electrical. Let's say, for instance, if you went in and checked the voltage in phase to phase, they were similar like they are now. And if you check phase to ground, and they are very similar, okay? They're somewhere in that range of what's nominal. You know, 277 to ground and 480 leg to leg. And that stuff looks normal. But when you get out here and you're checking your amps per leg, and all of a sudden you get one leg that shows up way less than the other, and you have a phase imbalance on current. Now, let me ask you a question. Do you think you've got a problem up this way towards the bucket, or do you think you've got a problem that way towards the motor? Towards the motor. Now, here's what you got going on. You got a resistance problem going on. There's something going on either with the connection in the pad head there, or you've got a winding that's got some resistance problems. You've got a winding possibly going there. That the windings don't have a bounce resistance in them. So again, when you see the amp speed, something wrong, not balanced, but yet the voltages are, it's nothing of it. It has nothing to do with the bucket and voltage source. There's something wrong with the load. The load's not drawing a similar amount per leg, even if it needs to be looked at the motor itself. I can show you how to do we can do this, say Tuesday. How do we do an insulation test on the motor? We have a meter for doing that, doing a meg test. And that can give you an indication between doing a meg test, each leg to ground, and then doing a resistance test through the winding. Between those two tests, it can tell you if the motor winding is down. So doing a resistance test through the windings could actually tell you, could explain why you're getting maybe low amps on one leg compared to the other two. If you get pre-resistance readings in there through the motor, if they're not similar, then there's something wrong internally in the motor. The winding, some winding to get into the power. So let's just plan on doing that Tuesday to do a motor test electrically with an insulation tester, and that'll help you. That's something that's very practical. Some folks don't know how to do that. So any questions about what we just did there? Okay. Now, when you get in the plant, you have some departments run all their motors on 480 volt, and then some departments run them on 240. So it depends on where you are. Here, you saw what the riggers are. If it says that they say it's a 480 volt motor, it's going to be 480 volt leg to leg. We said leg to ground. If this was a 240 volt power source here, it would be 240 volt leg to leg. But leg to ground, it would actually be 120 ampere. You kind of keep that in mind. And on low voltage on a bucket like this could be anywhere from 208 volt to 240 in that range. And if it was a 208 volt, it would be 208 volt leg to ground speed at 120. That sounds strange, but that's really good what it is. So if you're in that low volt 200 volt range, it's between 208 and 240 leg to ground 120. The motor controls that you have in January will be testing those voltages in both systems, in this system, and in the low voltage, the 240 system. You get some hands on that stuff. Okay? We're going to cut this off here, but look away from it. Okay? Yeah, thank you. Appreciate that. Thanks for the help. What's the bottom? We're putting a lockout device on here. They got lockout devices for most anything. That's a big old 40-volt three-phase plug. We've got a can for that. And so we're locking out the pigtail for the button instead of locking out the handle. It's actually the end pin coming. If we lock this out, there's still a risk on somebody plugging that in that's big a hot going in. So the safest thing is really to get the pigtail locked out. Woo. I think I lost 5 pounds wearing this stuff, which I need to lose. My doctor will be happy. Yeah. Okay, so and we're going to go over that way real quick and work in a minute. We got a couple minutes. I want to see. Let's see where Luke and Darren are progress wise on their project. We can roll this right up here and actually leave this right in place. That worked out pretty good. Okay, we can put a new hose on there. We can just get a couple. I can get a couple. We can couple. I have a couple. All right. So first thing I want to check here would be how close. I guess you can maybe set your camera over here. We want to look at the gap between these at rest, because when it comes together, it can actually cause this thing to flex. Okay, so let's take a look. It actually looks pretty good. It's been a while since I've seen this thing run. I can't remember. Let me get a couple. Let's couple this back together and let's engage the brake and just let's check this out before we ever turn anything on. I hope to see the brake engage and disengage. That may be a little bit tight. You might want to loosen that a little bit. The reason behind it is because this stuff in here, I don't really want to stretch out a whole lot.
It go all the way up for the first week.
That's probably a little more than that. And that still may be a little tight. That's probably, you feel that right. See what you think. For something like that, you talk to something that can. Yeah. Let me grab an air coupler for that 4-inch line, and I've got one.
everything's over real quick. I swear. Let me go back and get under this. Oh, good. No breaking here. No breaking here. Look here. Let me tighten it up a little more. Let's loosen it up a little more. One side, well, that side over there is pushing this way. This could be pulled out. Yeah, that's the stationary side. But this could be pulled this way. Stop. We turn this on and this sucker started spinning and snapped back in half. Oh, it's time to go. Get that through. How bad it'd be if we all just left.
I was thinking the same thing.
I'm gonna have a little fun here. So here we got a cut air line. A cut air line. We're in the jam. Got a couple, but here's what I have got. I got a T. So we're gonna have an open hole. So then we make a homemade plug because I didn't have a regular plug, so I made one with electric tape and a piece of tape. So you plug it in there, and then we've got us a.
That's the county job right here.
That's called get her done.
Get the plant running.
And we gotta get her going here, guys. The truck driver's been out there 3 hours waiting on this load. We're gonna be in trouble here. I gotta hurry up. Just make it run. Can't you just make it run? How much longer? Okay. How much longer? So we're not gonna put power on it right now. I want to see this engaged because my question is, I'm thinking that this one here was a stationary one, and if it is, then you need to bring this in further because the gap needs to be on the other end. The gap needs to be on, so it needs to be moved.
It's working.
But it's bending. So you need to make the adjustment. The whole thing needs to come this way and get it closer on this end so it doesn't flake the that.
NASCAR.
Mm. Yeah, NASCAR, yeah. You want to adjust it so there's doesn't have drag on it, but like you want to have just a little teeny tiny bit of the clearance on there. Yep. And you may even, you could just throw that same 10 thousandths in there. That'll give you a little clearance in there and see.
It's too much, dude. That's too much.
So well, I mean, that's not an exact spec for it.
Would you hurry up? You got 36 in that, don't you?
You hit it tight, it tightens it up.
Is it disengaged now?
What?
Right, you're gonna have to disengage the cuff on, yeah. Cuff. I'll tell you another thing I just thought about. It could actually be done, shims in another way. Down the bottom end. Break the shim, get shimmed over some. So I have to do all that. Hand wash on the bottom of it.
Pull it off and then move it out. Don't put it back on. What are you doing? You got the screw, just pull it right in there.
We calculated one line at the plant once. If it was down, it was $50 a minute. So every minute it's down, $50.
We lost about $200.
When you start talking about that coming out of people's check.
Yeah.
I think the boat on the calculation, the whole plant.
The whole plant now, that's good.
I think it's around $50,000.
That's a lot.
Something like that. The entire plant, if it was down, something major like that. If they had to evacuate for an ammonia leak or something like that, or something major, then I think it was around. I don't know, for some reason I think $50,000. I don't know. It's 50,000. So for a certain amount of time, I don't know if it was a minute or an hour or. So it's too tight now. Okay, let's see if we can do something a little easier, guys. What's involved in moving the whole shaft? If you loosen up the collars, can you just move the whole shaft in there?
Not good. It says screws on that.
Yeah, that's what I'm talking about. If you loosen those, you can move the whole thing. Then you can fine tune it. You can fine tune it from that point. And it may throw you off in here some. You may have to adjust the motor some, but that'd be easier right here. It would give you a more easier. That way you can actually tweak it, and it wouldn't be so hard to tweak it. No. Some things here in the shop is metric, some standard. I don't really remember. Yeah, there is some of everything. There is, yeah. Sometimes on a machine you can have some of both, depending on if the whole thing was built in Europe, or if certain components were built here and then certain parts of Europe. It depends. You know. Okay. Yeah. Understand. You got a job to get to. Yeah. But we can just, you can just, you know, if you guys, we can drop it right where it's at and just continue it on. Right. We can loosen them cars. It should let you move that shaft over and do a fine tune there on that clearance, and it not be so aggravating, you know. It is fine. We're actually over. We can do this Tuesday. It'll be fine. The shaft can be moved. It can be moved. Okay, and we'll just fine tune it that way. That'll be all right. So we're going to continue this thing Tuesday, and what he's having to do here is to get the gap set properly right in here. So there's drag on it right now. You've got to get it set so that there's just a little bit of gap in there. That's your stationary pad. Your moving pad is over on this side that engages with the air. So that's the moving one. Your backing pad here has got to be fairly close so that when it engages it, it doesn't warp. So that it doesn't jerk this right here and move it around and warp it when it clamps. The clamping's the right word. It's going to clamp from this side. You want the backing pad to be almost touching, but not. So, okay, you have to do them. I'll see you later. We're doing if you're not doing the lamps on 111, we're going to be finishing up lamps this afternoon. I'm not going to be able to make it. Okay. So anyway, we're going to set this gap up here so that it's got just a little bit of clearance on the backing pad, and that the main bit of your clearance is best and here in the moving part of the pad. So anyhow, so we're going to sign off on this session here. And I appreciate y'all, whoever's watching, being patient there, Brandon. You know, when you're doing the video here, it's it's like reality TV. You have to just, real stuff, real things you have to stop and do. We're in clutch and brakes now set up. We're going to be looking at couplings coming up pretty soon. Alignment. We're going to be getting into laser alignment. Conventional alignment and laser alignment we're going to look at sometime next week. How to line up shafts, like for pumps, between pumps and motors and things like that. How to do that in a couple of different methods. And so thanks for watching. And Brandon, I did put a new worksheet for Chapter 3. And it covers like preventive maintenance and record keeping. There's a new worksheet in there. Need to get that done soon because it'll be due in just a few days. Just check Moodle, and you'll see it in a section that says makeup work for November 17 and 19, because November 17, 19 are the 2 days that we'll miss in here because of a surgery I have planned. So November 12 will be the last day in the shop. November 12th. The next week on the 17th and 19th, you won't be in here for this class. During that week, you need to go ahead and go in Moodle and save your graded worksheets that I grade. Save those. And you can print them on paper to study by. All you got to do is go in, and when you click the particular worksheet that you've done and it's been graded, when you click it, on the right side of the screen, it'll say a button for review. So you hit review. It's going to let you see your graded results, and you can print either to paper, get a paper copy, which I would highly recommend having a paper copy, And you can also print to a PDF file. So probably the best thing would be start out, print to a PDF file instead of to a printer, give it a name, and you specify on your laptop or on your smartphone what folder you're going to put that file in. And when you print to PDF, it's on your device. So that your worksheet is saved on your device. And do that for all your worksheets, save them. You got them electronically saved where you can study them with my comments, and then you can print them on paper if you want to, but you at least need to do a PDF backup of all of them. Because once the semester is done, you can't go in there and view. You're not going to have access to the class. So your only records are going to be those. I mean, as far as work that you've done. So everybody does really need to do that. And I'll do the exam. Will be a few questions off of each worksheet. So it's going to come straight off the worksheets. Thanks for watching, and God bless y'all. Have a blessed weekend, and thank y'all for joining. If anybody's viewing that's not connected with the school, you can contact me at dking@sampsoncc.edu, and I'll help you if you have questions about registering for some classes. We do have some certificates. We have several degrees here in the maintenance field. The industrial systems degree, it contains a good multi-craft variety of classes. It has lots of mechanical classes, a little bit of machine shop, a lot of electrical. I'm teaching intro to electricity, residential wiring, motor controls, PLCs, and electrical maintenance for automation systems. And we also have, within that degree, you have some one refrigeration class and also a welding class. So you get a real wide range of what I would call multi-craft skill set that you can get in 2 years if you come full-time. Come part-time, of course, it's going to take you, 3, 4, 5 years, depending on when you're able to come, and then the rotation of the classes as they rotate around that. And that's a very slow thing, waiting on that. And then we have a new program called electrical systems technology. So it's a fully electrical degree, 2 years. And the classes, my electrical classes goes into that degree, and there's other things, commercial wiring and some solar stuff and electric code classes that go into that degree also. And then we have a HVAC degree. That's a pretty hot item there. That's a lot of folks have been asking for HVAC degree, and we've got it now. So that's kind of what you're interested in. You come on out, and we'll get you hooked up with that. We've got a welding degree, carpentry. We got lots of good stuff. So whatever you kind of have a hankering for, that you feel inside, that you feel drawn toward in an occupational field, you come on out, and we'll get you connected with something that'll suit you, that you would enjoy doing, making a living in. So thanks again, and God bless y'all, and we'll see you Tuesday. Have a nice weekend.